Speaking of reliability, a podcast with good friends talking with you about reliability engineering topics. Welcome to Speaking of Reliability. This is Fred Schenkelberg.
And this is Dianna Dini.
Hey, Dianna. In our last episode, we talked about sample size a little bit, and then we talked about test methods. And I was kind of like biting at the bit to go, well, I've had as many issues or more issues with that than trying to settle on a sample size.
The whole test method.
Yeah. And part of this prompted, because I saw a message, it was a couple of weeks ago, and it was a question about running a test, and it was a binomial zero failure style of test. I call those success testing. We have so many samples, they all have to experience this set of stresses and pass. And one of them failed. And so they pulled it out and put a new unit in there and said, well, we'll account for the hour it took us to replace it, and we'll just run the test an hour longer for that sample. And our test is still valid, right? I'm like, no. And then I went, except if you pull that sample out and you put it on the bench and test it, and it's still good, it's still a valid, hadn't failed, maybe something in your test rig failed that signaled a false failure for that product. Did you do that? Oh, no. We took it apart for other reasons and other samples, and, we just destroyed it basically. And I'm like, oh, you didn't even check what was the failure.
Because see, when something fails, that's when we get excited, right? We're like, oh, a failure. Why did it fail?
Well, they had a test plan that said it's supposed to all pass. And so they took that to heart and said, well, if it failed, that must have been a bad sample. Or we're just going to ignore that and put another one in there because we need to have X number of units run so many hours under these conditions. And so we'll just replace the one that failed with another one, independent of that you had a failure.
See, that's a big no.
Yeah. But they didn't quite understand the concept of a zero failure test. It's not do everything you can to get zero failures. No.
Yeah. And so they didn't know why it failed. They just took it out and
put another one in there. But what, based on our sample size discussion and that background, is in my own experiences, well, sometimes the test rig itself gives you false positives or false negatives. And, I learned it the hard way is that, well, I'll take that unit that's being signaled bad and I'll shift it to a different set of leads, basically on the system that's doing the detection, whatever the detection method is, and put a unit that the system is saying is good right now over to the unit spot where the failed one was, and then run a cycle of the diagnostics again. And if that same position is signaling a failure again, let's check the cables. Let's check the software. Let's do something to make sure that the test system itself is not giving us the false failures, the false signals. And then the opposite extreme is when you're running a test and everything fails like immediately. Like, it seems unreasonable. Maybe we're, let's make sure the temperature is right and everything else. And like, we have
I'm just picturing that scenario. That's terrible.
You get it all set up in the chamber. You got all this equipment, all these sensors hooked up, and all this stuff. And you're reading all this stuff, and you turn it on. You just want to make sure it's reading everything, and it goes, sample 1 failure, sample 2 failure, sample 3 failure, sample 4 failure. It's going right down the line. I'm like, what's going on?
It's funny because it's not funny. That's when your stomach drops. You're like, no,
we're not done yet. And we're on a timeline. We got to get this thing going. And sometimes in that case, it was the test engineer I was working with to do the electrical circuit testing on it. Set the criteria like on the components. It was it was failing because it was detecting a resistor that was a 100 ohm resistor, and the criteria was 100.000 ohms.
Oh,
And it's a 20% resistor. And I'm making up the component at this point. And resistors, or any electrical component, is not that precise ever.
no.
You can pay a whole lot of money and it'll be plus or minus 5%.
There's variability in everything.
There is. And the test engineer said, well, you want 100 ohms there. So he just put 100 ohms. And I'm like, nothing's going to, there'd be a random chance that one of them will get that number, but very rarely. And oh, okay. So he put, oh, I can put little boundaries on there. Okay. How precise should it be? And like here, and everything was up and running, but it was like, what in the, it took us a while to sort it out. It was like, what in the world's going on? We were checking cables, we're checking, the samples, we're swapping positions, we're rebooting it. And it was like, it was in the test software, the coding for the software that ran the test. Oh, bother.
Yeah, that's that root cause analysis. And so, yeah, so the stories you're telling is it's the test method. It's not necessarily your piece, but there's something wrong with your test method setup that.
Well, that's not the only problem though. It's the, and part of it is the test method. I agree. Yet any measurement system, right? There's a measurement error. And
Yeah.
that measurement error is not to be ignored when you're setting up and running any kind of experiment or test, because it gives you, part of that goes into that type 1, type 2 error. And I think everybody's eyes just roll back in their head going, oh man, that old statistic stuff, we got to think about that.
Yeah, I know.
But yeah, if the measurement system you're using kicks out some even 10% measurement error, there's a probability that you're going to have a perfectly good unit signal that it failed, or vice versa. And unless you take that into account as you design the test or think through your testing, you can be chasing phantoms and inadvertently chasing phantoms. And so it's one step beyond sample size. It's, you got to do the due diligence to make sure your ability to measure your system works. Then again, I ran into a guy that said, oh, we'll just take a couple samples, throw them in the chamber, come back next week and see if they're still working. Are you going to power them while they're in there? Oh, no. It's too much pain. We'll just warm them up.
So what? So he was, so he was baking them and then going to pull them out and test them, or?
Yeah, and like if you're going to test them for moisture content, and they're going to be lower moisture content, but so what is temperature all by itself going to do to your product? And it was not much different than a block of titanium. It was like, what is it going to do to this thing? Yeah, and it's just high temperature over life test. It's a standard. We just put it in at 85°C and let it run for 176 hours, I think it is. And if it works when we pull it back out at room temperature, then it's good. Well, it's good for what? He couldn't answer that. It's just good. I'm like, no. What are you actually measuring here?
There was, we get into trouble a lot with packaging testing because you create all this packaging and, the foam and the clamshell things and everything, and you get it all packaged. And then there's these shake, rattle, and roll tests that simulate shipping a product from the factory to wherever you're going. And depending on where you're shipping to, it dictates some of the aspects and parameters of your test. And there was always a problem with, like, oh, well, it rubbed a little bit here, or, or
cosmetic type looking things.
Yeah, cosmetic things, or something happened with the test equipment that it would just stop working over the weekend. So then we had to do something different or adjust our test plan for that kind of thing. That I just remember those packaging test setups. There's always something going on with them. It's a rough test.
It is, the drop in vibration and temperature swings, stuff like that. And there's
Yeah.
labs that are set up with it. They have the big platforms and they drop them in different angles and all kinds of cool, wicked stuff to your product, your packaging. Um, it One of the things to keep in mind in any experiment we do, where we're trying to understand what it's going to do in the customer's hands or in the shipping system, is nature has the advantage of us is they can apply all these stresses in random order or simultaneously at will. The world itself, its environment that we put our products in, is a master at saying, well, I want to do high temperature and humidity and vibration. Oh, and I want to have some bunch of dust in here, and we're going to bring in some fire ants, and we're just going to do stuff that
Yeah.
you just can't do in the lab. And not even NASA. I was getting a tour of the NASA test labs years and years ago, and their vacuum chamber was big enough to put the entire space shuttle in.
Wow.
It is that, and then they would get the vacuum of space. And he goes, we can do solar radiation, we can do this and that, and all these other. He listed all kinds of stuff. He says, but we're working on gravity. We have a hard time getting rid of gravity in here. Oh, bummer. Let me know when you figure that one out. The amount of money they spent doing that is extraordinary,
Yeah.
and for good reasons, is they're putting this system up with people in it and they want to make sure it actually is safe and works, kind of thing. And it was also used for training and for all kinds of other things they were doing. But our ability in the lab to have blowing dust on a vibration table with high temperature, high humidity is, I actually asked a company that made test rigs and stuff like that. And they said, no, it would destroy the system itself before it was ever useful for you. Is you add all this stuff to a pneumatic hammer under the table, all of those other conditions you're putting in there are going to destroy that device. Like, okay, never mind. So oftentimes we resort to doing sequentially. It says, oh, we're going to do the freeze thaw first, and then we'll do this one, and then we'll do
Yeah.
that one. It's just not the same as being in North Dakota for the winter. It's just not the same. And part of that gives us a sense that either we've overstressed it or we're being conservative and we say we'll do worst case, and then we get failures. And well, is that really a failure customers will see? And then vice versa, is that we don't put the right combination of stresses together that really does destroy our product pretty quickly. So besides measurement error and test rig setup and stuff like that, there's also just the constraint that it's really hard to replicate the true conditions.
So back to the FMEA and hazard analysis and
Mm-hmm.
stuff, that can kind of help you think through some of those scenarios.
Mm-hmm.
I remember there was a product design and it was plastic. It had a gel in it. It was a gel in a tube, like an expandable tube.
Mm-hmm.
And we wanted to take it to some physicians and say, hey, try this out. What do you think about it? So there had been shipping tests and, product verifications and validations and all that stuff. And we
Mm-hmm.
decided to share it with some salespeople. So the salespeople called back and like, this thing's a piece of junk. It exploded.
Oh.
Oh no, what are you talking about? Well, the gel's all over the place, like the rubber expandable thing, it expanded and it squirted the goo all over the inside of this product. Like, this is not good. And we're and
Yeah.
we were thinking, man, we did all these tests. What could have caused that? And here the salespeople were in their car driving around to
Mm-hmm.
different. You're already laughing.
Yeah.
Driving around to different hospitals, and it was in the middle of summer, and they were in the Midwest, and it was like in the high 90s
Mm-hmm.
outside, and they put them in their trunk of their car and just left them in there. So then in the trunk of the car, it was reaching like astronomical temperatures. And we're like, well, no wonder, no, we wouldn't have thought a medical device would be in the trunk of a car in the Midwest in the summer for days baking.
Yeah.
and
I
it
left it in the
failed.
car over home. I'm at the hotel waiting for the doctor's office to open on Monday, and it's just in the car. Yeah.
Yeah. And where we're going to the beach, driving through the desert. I
Yep.
don't know.
Yeah.
But yeah, so that was I guess that's not necessarily a product test. We were kind of showing it to customers to get input and that kind of stuff. But we were shipping
Well,
it and people were handling it. So we wanted to get the feedback and the input, but that was just something we didn't expect.
yeah, it was hard to get the sample to them in the right. But it's actually, I one of the guys I worked with years and years ago when I was at Hewlett Packard, who sat across from me, was the packaging guy, kind of the internal expert on packaging. He did all kinds of cool stuff, but he said, "Hey, check this out. This is the upper rack of a UPS truck in Tucson, Arizona in July, and it was 190 degrees."
Wow.
He said, "Yeah, they close up their trucks and lock it, and they go to lunch, and there's not enough shade." So it just really heats up. And like, oh my, we don't test anywhere near that for, an exposure like that in transit. And he goes, yeah, that's the problem. We're working on that.
Yeah.
But it's just until you get out and actually see how it's used in the different conditions. And I've run into the prototypes going with sales folks, and I've often wanted to tap into those going, well, what are you seeing? How are people using this? How is it? What's the installation type damage? What's the startup type problems? What's what are you seeing?
Yeah.
And they're often like, hey, I got 6 appointments today. I don't have time to tell you all this stuff. And like, if you want a product that you're going to sell, you should tell us and find a few champions that would give us feedback. Um, some of it, though, is I think the issues that we see, and one of them was an article. I talked to Chris about it a couple of weeks ago. It was a article that was about the life of car batteries, the lithium ion batteries in electric vehicles, in reality last much longer than the test results.
Oh, that's a nice change, huh?
Yeah, it could go the other way just as quick, depending on how you run the test. But they were running the tests being, here's a new technology. We're putting all this stuff together and we have these temperatures. And they figured that it was the cycles of charge and discharges was the thing that was going to limit the life of these lithium ion batteries, not counting accidents and stuff like that. And so they would rapidly discharge and rapidly charge the batteries as a way to get the number of cycles they needed very quickly. So it was a just force the charging and discharging, full discharge, recharge kind of thing, as quick as they could.
Okay.
And it turns out people driving electric vehicles don't do that. I'll drive 30 miles to work, plug in at work. I go to the store, I plug in while I'm in the store. So I have a modest discharge and a modest recharge. And when I get home, I plug it in, it's fully charged. And it really wasn't completely discharged. It's not driving at 600 miles and rolling into a quick charge station as my day in and day out activity. People don't tend to drive like that with electric vehicles. And so they're saying it's like a 40% longer lifetime than expected. And it's kind of a good thing. Yet if you do a testing and you don't really understand the mechanisms and what you're accelerating, and you run what looks on all the surface to be a perfectly good accelerated test, it may underestimate it will give you a 20-year lifetime when it's really 10 years because you're
Yeah.
accelerating the wrong things or stuff like that.
It really comes back to the use case, right? How
Mm-hmm.
people are using it, where they're using it, the environment that it's in. Really understanding all of those things is an important aspect of setting up these tests.
Yeah. So I think in summary, it's kind of like there's measurement errors and test rig failures that are the failure of the test rig itself because you're putting it also under stress. That may or may doesn't reflect your product doing it. Then there's just what was the second one? I already forgot, Diana.
The I don't know. It feels like we've come full circle, Fred.
Yeah, but I think there's measurement error, test faults where the test method itself, test method issues. The test method's working just as it's like designed to do, but it's designed to give you failures when there isn't one, or vice versa, kind of thing. And then there's the complexity of replicating all the stresses simultaneously. So we sometimes do it sequentially, sometimes we do it worst case, things like that. And it gives us results, maybe conservative, maybe not. And there's some error in the results that's beyond the statistics because of the inability to replicate how people really use the product. Like, don't give it to salesmen in Midwest in the summertime when you have a heat sensitive device.
Yeah, exactly. Lesson learned.
Yeah. I don't think it's possible to test for everything in most products and most systems and most factories and so on. And there's a bit of engineering judgment. I think your mention of the FMEA is spot on. Is like, let's focus our $100 on what we really need to learn about. We really just can't test everything. So let's focus on what we need to know and why do we need to know, and sort that out first, and then go set up your test. But pay attention to all those other factors that could give you false readings out of your evaluations. Because it's kind of embarrassing when you say, oh, yeah, it's good, and then it fails out of box when it gets there, kind of thing.
Yeah. Yep. So risk is a good input, and knowing your customers and how they're going to use it, what's important to them, is also a good way to prioritize. Yeah.
So if you run into some scenarios where you think you're doing a good test and it fools you, or vice versa, if you caught it and did something about it, let us know. We'd love to hear about that kind of stuff, because a lot of us do a lot of evaluations and testing and modeling and all kinds of stuff, and we try to make conclusions that are useful for the decision makers for all kinds of different purposes on our work. What do you find helps you get it right more often than not? And that'd be great to learn about more of that. Let us know. Head over to accendoreliability.com/go/SOR. You can find a couple of ways to get in touch with us. Dianna and I, in our error-proof system of communication, which is not true, you can reach us through LinkedIn or our About pages. So we have three-way redundancy systems here. And if you can send us a written letter, we'll probably even respond to that. That'd be just fine. But plenty of ways for you to get in touch. If you'd like this topic or want to expand on it, that'd be great. If you have other ideas or suggestions, we're always looking for that. And we'll wrap it up there. So thanks so much, Dianna, for jumping in on other things to consider when you're doing testing.
Yeah. And we're at the end of the episode here, and I'm thinking we should have had this as an April Fool's episode.
Yeah. Well, it was yesterday. We have to plan ahead for next year.
Yeah, I think so.
Our recording errors are off of that year. We could have done that.
Nice to talk with you, Fred.
Yeah, same, Dianna. Appreciate it. And we'll talk again soon, I'm sure.
Okay. Bye.
Bye. Thanks for listening to Speaking of Reliability. We invite you to join the conversation. If you have a question or a topic that you think we should discuss in a future show, please let us know. You can find a comment box below the episode show notes, or just leave a note as part of a review on iTunes.